there's a person. Is having velocity UR and velocity will be V1. The disk don't show V2 or if you want to show V2 or let me write omega 2, that's all. And this particular point tangential velocity will be V2. V2 of what? V2 of the disk. Tangential velocity. No. Directly getting to conservation of linear momentum. What is UR? UR is equal to V1 minus of minus V2. No? If I take this direction positive. So UR minus V2 equal to V1. This much is what we have. How to what is V2 further? R omega 2. Agree this one? Okay, how to what to write here now? Net torque will be 0, no? Because how the friction will act, the friction on the person will act like this. On the disk, it will be like this. Huh? So net torque about O will be 0. Then applying conservation of angular momentum. LOZI equal to LOZF. Initially, person and the disk are at rest. Then the person starts running. So initial angular momentum is 0. Final angular momentum M1 V1R, that of the person, minus IO omega 2. So if you are, so what is the sign I'm not getting? At least I think you can clockwise. And what about this? Anti-clockwise. So 0 equal to M1 V1R minus moment of inertia of the disk M2 R square by 2 omega 2. V1 we don't know, that I'll substitute here. So this will be M1 UR minus R omega 1 M1 UR is equal to M1 omega 1 square R omega 2. M1 R square omega 2 plus M2 R square by 2 omega 2. M1 U1 R by M1 R plus M2 R by 2. Fine. So this will be the angular velocity of this one. Okay, now I'll ask you one thing. When the system was at rest, person and the disk were at rest, no? Then they start moving. The person is having kinetic energy. The disk is having kinetic. From where this energy will come? From where this energy will come? So some external agent will give. Where is the external agent? Person and the disk are there, no? From where the external agents are there? Nothing. So the axis will give. Why axis will give? Why the axis? I'm writing fixed axis. I think everyone should know that one. The disk is not permitted to undergo any linear displacement. Fixed axis here. It can only rotate about that axis. And now tell me from where that kinetic energy will come? The work done by the person. The decrease in its mechanical energy. Its physical strength will decrease. Where it will go? It will get converted into increase in its kinetic energy plus rotational kinetic energy of the disk. They may trouble you with these things. Huh? The decrease in mechanical energy of the person or nothing but the decrease in muscle energy of the person should be equal to increase in kinetic energy of the person plus increase in kinetic energy of the disk. Okay, person is there now is running and you'll make a jump. I think in SURMA you're having some series of problems like this. Some around 4 numericals are there. So just try to V2 is a tangential velocity. Huh? V2 is the tangential velocity of the disk. I should come from here. This is the idea. From here is what I should enter. So for that, I need tangential velocity. Tangential is what? R omega 2. I think problems are very simple, but lot of thinking is needed. You should understand the diagram very clearly. I think we can manage situation. Let me give one more here only. The disk one. I'll give one more situation. Okay, there's a disk of